Okay, so we are going to now be transforming graphs. And so for each of these, we are going to use this parent function that's given to us, f of x. And so for number 1, what we're going to do is we are going to translate every single point up 3 units. So your point, -4, 1, if we start at -4, 1 on the graph, we're now just going to move up 3 units from there. Your next point on the parent function is -1, 1. So if we start at -1 on our new -1, 1 on our new graph, we're going to now move up 3 units from there. Okay, and we can start to connect those 2 points together. Now my next point is 1, 3. Starting at 1, 3 on my new graph, I'm going to move that point up 3 units. And now I can connect these 2 points together. And my next point is 2, -3. So starting at the point 2, -3, on my graph, my new graph, I'm going to move that up 3 points. So this is my next point. And then finally my last point, which is the point 4, 0, I'm going to start at 4, 0 on my new graph and then move up 3 points. And this is what your graph looks like when you translate it up 3 units. Okay, we're going to do the same thing with number 2, but this time we're going to be translating all of my original points down 2 units. So we're going back to the original graph. We're always going to start from this original graph. And so -4, 1, I'm going to now translate that down 2 units. -1, 1, I'm going to translate that down 2 units and connect those two together. 1, 3, I'm going to translate that down 2 units. 2, -3, I'm going to translate that down 2 units. And then lastly, 4, 0, translating that down 2 units. This is what your whole graph looks like shifted down 2 units. So then for number 3, we are going to be shifting to the left 1 unit. So starting at -4, 1, shifting to the left 1 unit, I'm now at -5, 1. -1, 1, I'm going to shift that to the left 1 unit. 1, 3, I'm going to shift that 1 unit. And then 2, -3, I'm going to shift that 1 unit. And then lastly, 4, 0, I'm going to shift that 1 unit. So this is what your graph looks like. All right, so for number 4, what we're going to be doing is we're going to be multiplying our y values by 2. So if I start at the point -4, 1, I'm going to multiply the y value of 1 by 2. So a 1 times a 2 would put me at -4, 2. The y value on the next point, -1, 1, I'm going to take the y value of 1 and multiply it by 2. So now I have the point -1, 2. For the point 1, 3, I'm going to take my y value of 3 and multiply it by 2. So that now puts me at 1, 6. I'm going to connect all these for right now. The point 2, -3, I'm going to take my y value of -3 and multiply it by 2. So I get a 2, the point 2, -6. And then the point 4, 0, if I multiply my y value by 2, a 0 times a 2 is just a 0, so that point stays where it's at. Okay. So now number 5 is a reflection in the x-axis. And what we do is we multiply our y value, or we make our y value the opposite sign. So -4, 1, my y value of 1 is now going to switch to -1. So I'm going to have the point -4, -1. So then -1, 1, my y value is going to switch to a -1. So I now have a -1, -1. The point 1, 3, my y value is going to switch to a -3. So I now have the point 1, -3. The point 2, -3 is now going to become 2, +3, because my y value was originally negative. So the opposite of it is going to be a 2, +3. And then 4, 0 is not going to change because 0, the opposite of 0 is just 0. So that's what my new graph looks like. And then number 6, this time it's a reflection over the y-axis. So this time it's your x value that's going to become the opposite. So if I have the point -4, 1, it's now going to become 4, 1. And if I have the point -1, 1, it's now going to become 1, 1. And if I have the point 1, 3, it's now going to become -1, 3. And if I have the point 2, -3, it's now going to become -2, -3. And then lastly, if I have the point 4, 0, it's now going to become -4, 0. So this is what your graph would look like. It just flipped over the y-axis, so it flipped the other way around. Okay, so now we are going to graph based off of parent functions. And so here's where the parent functions come into play. And it might be a good idea for you guys to know what the parent functions look like. So for number 7, this is a quadratic parent function. So in a quadratic parent function, it is a good idea to know where your points fall. So one of your points or your vertex of your U-shaped graph is going to be at the point 0, 0. Another point on the parent function of a quadratic is going to be 1, 1. And a quadratic or U-shaped graph has symmetry, so we also have the point -1, 1. What symmetry means is if I folded that point 1, 1 over the y-axis, then it would land on top of my next point, which is -1, 1. And then I also have the point on my parent function 2, 4. And then, since this graph has symmetry, another point on that parent function would be -2, 4. Now, how I'm getting this is I'm using y is equal to x squared. And when we're using an x and y table, we can choose the first 5 x values. I typically choose -2, -1, 0, 1, and 2 always. Because they're low values and I'm getting 2 negative values, I'm getting 0, and I'm getting 2 positive values. So when we're trying to graph using an x and y table, we choose our x values. And then what you do is you put those x values in for x in your parent function equation, which my parent function for a quadratic is y is equal to x squared. So if I put -2 in for x squared, a -2 squared is a 4. So that's how I got the y value of 4. If I put -1 in for x squared, a -1 squared is a +1, so that's how I got a 1. If I put 0 in for x squared, a 0 squared is a 0, so that's how I got a 0, and so forth. All right, now I'm going to draw my parent function using a dotted line because this is not my actual transformation. This is not my ending graph. I want to transform this function by doing a vertical stretch by a factor of 2, and also doing my translation to the left 1 unit. So what I'm going to do is I'm going to take the point 0, 0, and I'm going to move it to the left 1 unit. Now what's going to happen is the slope from my parent function, my rise from my parent function is going to be multiplied by my stretch of 2. So my rise is up 1, and then my run is over 1 to get to my next point. So what I'm going to do is I'm going to multiply my rise by that stretch of 2. So my rise was 1. 1 times a 2 is a 2. So from my from my point that I've just moved from 0, 0, so my point -1, 0, I'm going to go up 2 and over 1. And this is my next point on the graph. Since a quadratic has symmetry, I can just automatically graph the next point over on the other side of that -1, 0 point. And then now I'm going to check my rise from the next 2 points in my parent function. My rise is up 1, 2, 3, and my run is over 1. Your run's always going to stay the same. It's the rise that we're going to multiply. So my rise was 3. I'm going to take that 3 and I'm going to multiply it by my stretch of 2. A 3 times a 2 is a 6. So from that point 0, 2 on the graph, I'm going to go up 6. 1, 2, 3, 4, 5, 6, which means I'm going to go off the graph a little bit and then over 1. And then a graph has symmetry, so I'm going to just reflect that point on the other side. And so this is what your graph, your new transformed graph, is going to look like, and it's going to remain in a U shape. Okay, so next is absolute value. And so we can do the same thing by graphing my parent function. Y is equal to the absolute value of x is my parent function. Doing an x and y table, I'm going to pick the x values randomly as -2, -1, 0, 1, and 2. Putting a -2 in, the absolute value of a -2 is a +2. Putting a -1 in, the absolute value of -1 is 1. The absolute value of 0 is 0. The absolute value of 1 is 1. And the absolute value of 2 is 2. So now I'm going to graph my parent function. 0, 0 is my vertex, or the lowest point on the graph. And then I have 1, 1, and 2, 2. And I also have the ordered pair -1, 1, and -2, 2. Now an absolute value graph also has symmetry. Again, that means that if you folded it along your lowest or highest point, one side would match the other side exactly. An absolute value graph is a V shape. And I'm going to do a dotted V shape because that's not my ending transformation. So now I'm going to do a stretch of 2, a translation to the left 2, and a translation down 3. So my 0, 0 point, I can just translate it down 2, or sorry, left 2 and down 3. And then my slope between my first and second point is up 1 and over 1. We take our rise of 1 and we multiply it by my stretch, which would be 2. A 1 times a 2 is a 2. So that means from my new blue point, I'm going to go up 2 and over 1. And then I'm just going to reflect it. So my new slope is 2. Then between my next 2 points, my rise is up 1 and over 1. So same thing, I'm going to multiply my rise by 2. So 1 times a 2 is a 2. So from my new blue points, I'm going to go up 2 and over 1. And then I can reflect that point. This is your newly transformed absolute value graph. Okay, so the next one here is a square root. For a square root graph, your x and y table are going to be, you can do -2, -1, 0, 1, and 2 if you want. But I'm going to show you with this how it doesn't work out for us. If I put a -2 in for, in my parent function, if I put a -2 in for x here, the square root of -2 is an imaginary number, and we cannot do the square roots of negative numbers in algebra. So same with the square root of -1. We can't do that. We're not going to take the square root of negative numbers. I'm going to have you continue this on in the next video.